Hello, everyone, and welcome to our webinar. My name is Bob Cusick, and I will serve as moderator for the session. Our speaker, Kyle Tilley, and I both work for APA, the Engineered Wood Association. Our topic today is titled Simplifying IRC Wall Bracing Requirements. This presentation clarifies the pathway to streamline IRC wall bracing prerequisites through the utilization of the APA wall bracing calculator. The hour-long session provides advice on project setup, design flexibility, and wall bracing techniques, walks participants through an in-depth demonstration of the calculator. APA is a nonprofit trade association representing manufacturers of a variety of common structural engineered wood products. In addition to quality verification and product testing, APA conducts research to improve engineered wood construction systems and educates users and specifiers on the product's proper use and potential applications. Before we start today's webinar, I need to cover some housekeeping details. Kyle's presentation will last about 50 to 55 minutes. Handouts of the slides can be found in the control panel on your screen. To ensure that everyone can hear the webinar clearly, we have muted all participants. While we are bookending the discussion with our cameras on, we will be turning them off during the session to maximize the connectivity of the webinar. During Kyle's presentation, we encourage you to submit questions by typing them into the questions pane on the control panel on your screen. We will answer some questions in a Q&A at the end of the session as time permits. I'd also like to note that today's webinar is approved for AIA and ICC continuing education credits. After the conclusion of the webinar, you can get customized certificates of completion. I'd also like to point out the information provided in this webinar is based on APA's research and field experience. No warranties expressed or implied are made. APA and its members are not liable for any damages resulting from the use of this information. Users should consult local regulations and/or a design professional to ensure compliance with relevant codes and standards. APA does not control workmanship quality or usage conditions, so it cannot guarantee product performance or design outcomes. The content is copyrighted, and reproduction or use for AI training requires written permission from APA. Your feedback is important to us. I'd like to point you to a QR code on your screen. If you open your camera on your smartphone, a link will pop up to take you to the survey on this session. Our presenter today is Kyle Tilley, Engineered Wood Specialist for APA based in the Atlanta area. Kyle consults with and conducts workshops for designers, code officials, and other building professionals on best practices for specification, selection, and application of engineered wood products. I will let Kyle provide you with more information on his background before joining APA in just a moment. For those of you just joining us, welcome to our webinar, Simplifying IRC Wall Bracing Requirements. I'll now turn the microphone and the camera over to our speaker, Kyle Tilley.
Thank you, Bob. Well, prior to joining APA, I spent 5 years as a certified building inspector, and then I was recruited to become a lumber salesman, and I spent 10 years as a lumber salesman in Metro Atlanta. I then moved on to work for builders, a couple of builders in the Atlanta market, and then I acquired my license to be a residential builder through the state of Georgia. And I was lucky enough to land here at APA, where we can bring you information like this. And we're excited to have everyone in attendance for our session today, which is titled Simplifying the IRC Wall Bracing Requirements. We'll discuss advice on project setup, design flexibility, wall bracing techniques, and we'll walk participants through an in-depth demonstration of APA's wall bracing calculator. First, a little helpful information about APA. APA has 4 divisions. The Market Communications Division maintains over 650 free downloadable documents, as well as the APA website. The Technical Services Division is staffed by experienced engineers, scientists, and engineering technicians. That staff evaluates market needs and opportunities that best serve the industry. This division is also home to APA's help desk, where hundreds of calls are answered monthly from across the country. The Quality Services Division provides certification to ensure that APA manufacturers conform to APA product standards and policies. As part of the certification process, APA member mills are subject to ongoing manufacturing audits and inspections to ensure conformance to the product standard. Lastly, we've had a recent update to show how our field team is now working on a broader scale. The field services team is now under market access and development, which consists of engineered wood specialists located throughout North America. The engineered wood specialists provide information and recommendations to construction and design professionals. With our objectives today, we want to identify performance implications of wall bracing in single-family homes, list the benefits of early wall bracing design for enhancing window layout and material efficiency, be able to identify when to use prescriptive wall bracing, engineering, or a combination of both. And we'll discuss how the APA wall bracing calculator's output streamlines the plan review process and provides optimal constructability during the building plan implementation. We will achieve our learning objectives by reviewing the load path and wall bracing details, plus show examples of when these wall bracing requirements are not met. We'll describe some key benefits for designers, code officials, and builders. There will be an example shown using the wall bracing calculator. On our website, there's a downloadable quick start guide for the wall bracing calculator. We've included the quick start guide for you to download today. From APA's homepage, if you click on the Design and Build tab, you can find a quick link to the wall bracing calculator. When you land on the APA's wall bracing calculator's homepage, you'll see a short video there which introduces the calculator. You'll see on the left navigation bar, input project information is highlighted. So we need to input the project information on this page. We enter the information for the builder. We have the house plan or building name. We add the development address. And then you choose which version of the code you want to use. In this case, we're going to choose the 2018 IRC. Our seismic design category is going to be 1 and 2 family in seismic design category AC. Our design wind speed is going to be less than 115, which is common across many areas of the United States. Next, we'll choose exposure B for the wind category. We're going to have a 2-story structure, and our mean roof height is less than 30 feet. And once we've made all these selections, you'll see a icon appear where you can start inputting your plan information. You'll also see 2 other tabs appear in the navigation bar on the left. You'll see the View Project Report and Input Wall Line Information are both added over there, and those 2 buttons will be active. A couple of resources that you may be interested in are the guides to the IRC wood wall bracing provisions. These guides not only provide information on wall bracing, but they also include examples. All of the guides are authored jointly by ICC and APA. The 2012, 2015, and 2018 guides are available on the iccsafe.org website, and the 2018 Wood Wall Bracing Provision Guide now comes with the 2021 supplement for free. The 2018 version is the latest complete wood wall bracing provisions guide. They can be accessed from apawood.org/wall-bracing. And as mentioned earlier, the APA wall bracing calculator can adapt to the IRC versions 2009 through 2021. Section R301.1 of the IRC states that structures shall result in a load path that transfers the loads from their point of origin to the foundation. But how do we accomplish this using the IRC? Structures are constructed as prescribed by the IRC are considered to comply with the requirements of this section, where braced wall panels are one part of the complete load path, and the APA wall bracing calculator can be a quick solution to help meet these requirements for wall bracing. The required load path is achieved by following the provisions in the IRC chapters 4, 5, 6, and 8. When these provisions have been met, the load path is assumed to exist. Chapter 4 covers foundations. Chapter 5 is on floor construction. Chapter 6 is on wall construction. And chapter 8 covers roof and ceiling construction. This presentation focuses on Chapter 6, the section on wall bracing. If we turn this house on its side, would it stay together? The connections that resist gravity loads are not likely to be adequate to hold the house together if it's turned on its side. Think of lateral forces as when the house is tipped on its side, or when the loads are acting sideways on the house when it's upright. Studs by themselves have very little racking resistance. When a load is applied to a wall, nailed joints between the studs and the plates act like hinges. If you've been out on job sites, you see walls being stood up without sheathing on them. You see them start to rack over, and this is where you see the hinging effect on a lot of job sites. When a panel type product is attached to wall framing, its ability to resist forces is imparted to the wall framing. The ability of a panel type product to resist loads is dependent on the physical properties of the panel, primarily its strength and rigidity. The panel type products resist being forced out of shape. The more panels that are added to a braced wall line, the more resistance or strength you get. Fasteners are required to be at 12 inches on center in the field and 6 inches on center at the perimeter of the panel. As we've seen in previous slides, the load path travels through different levels of the structure. We'll be focusing on the walls for our goal of using the wall bracing calculator. IRC allows the combination of prescriptive and engineered design. The only portions of a house that do not meet the prescriptive requirements of the code need to be engineered. The 2021 IRC section R60210 wall bracing covers 35 pages with 16 different tables and 20 different figures. These pages also include 16 different bracing methods listed in table R60210.4, and we'll be using the continuous sheathing method with wood structural panels referred to as CSWSP on future slides. As just stated, there are 16 different bracing methods, with 12 being intermittent bracing methods. Here you see the 12, and I'm not going to read all these off. You see let-in diagonal bracing, not something we see used very much anymore, but we also have alternate braced wall panels, portal frame with hold downs, and portal frame at garage, which we will see. In addition to the 12 intermediate methods, there are 4 continuous sheathing methods. For all continuous sheathing methods, the wall lines must be fully sheathed, including the gable ends. Alternate braced wall method, portal frame at garage, and portal frame with hold downs may be used in both intermittent and continuously sheathed braced wall lines. Wall bracing is the IRC's prescriptive solution to resisting wind and seismic events. Across the country, most homes are built in accordance with the prescriptive provisions of the code. To use the prescriptive construction, the designer is limited to a maximum building size, maximum wall height, and normal lateral loads. Normal lateral loads are considered to be wind speeds less than 140 miles an hour and exclude high seismic activity on loose soils. Braced wall panels are prescriptive elements of a structure that resist lateral loads. If the house design exceeds the prescriptive limitations of the code, the house will have to be engineered. Engineered design uses shear walls to resist lateral loads. The shear walls are engineered elements of a building and require calculations. The areas shown in purple are where wind design is required, or the ultimate wind design speed is 140 miles an hour or greater. The IRC wind design provisions do not apply, and alternate standards, or the IBC, must be used. Areas in blue are special wind regions that require the designer to check with the local building official to determine the ultimate design wind speed for that location. Table R 602.10.3.1 help determine the required length of bracing by locating the correct row and column using the wind speed, story location, braced wall line spacing, and bracing method. The required length of bracing using method CSWSP for the bottom of a two-story home in a 110-mile-an-hour wind region is 15.5. This example shows how one finds the required length via the IRC, where the wall bracing calculator will have selected the correct length without having to reference a code book. And that's one of the benefits of the wall bracing calculator. If you do have different versions of the code lying around, you don't have to go out and select the right one. The wall bracing calculator already has done that. Once you have your bracing length from the table, you're able to take adjustments. Some adjustments may be able to require the length of that bracing. And if you ignore that, maybe you're being a little too conservative. But there's also adjustments that may double the length of the wall bracing requirement. And you don't want to ignore that one because code officials will probably end up catching you on that part of it. So the adjustments need to be looked at instead of just taking the table, put numbers on the table. Make sure you consider the adjustments. And here are the adjustments that you can take. You have the wind exposure category, eave to ridge height, story height, number of braced wall lines, 800-pound hold down on the top story, application of interior gypsum board fastening, and the one that can increase the amount of required blocking is horizontal blocking. So you want to make sure you're taking a look at these adjustment factors. The first adjustment factor we'll look at is wind exposure category. There's not currently an adjustment factor for a mean roof height in terms of height in feet. Adjustment factors are based solely on the number of stories. Note that table R 602.10.3 parentheses 1 is based on exposure category B. So the values here for exposure B are 1. Next on our list of the 7 items is roof eave to ridge height. Note that in the table, it's based on a 10-foot eave to ridge height. So adjustments for 10 foot here are 1.0. We move on to an adjustment factor for story height. Note that table R 602.10.3 parentheses 1 is based on a 10-foot wall height. So adjustments for 10 feet here are 1.0. This is a code discrepancy. Table R 602.10.3 parentheses 1 is based on a 10-foot wall height. The table for R 602.10.3 parentheses 2 is based on story height. The 2024 IRC has corrected this discrepancy to coordinate the two tables for the use of the wall height. So are builders and designers taking advantage of a reduction when they have a 9-foot first floor, or is that 10-foot first floor number being used from the table and the deduction is not being taken? Note that in table R 602.10.3 parentheses 1 is based on 2 braced wall lines. So the adjustment for 2 braced wall lines is 1. The adjustments for all parallel lines are not just interior lines. On occasion, an exterior wall line will require 2 separate braced wall lines. Use of footnote C is uncommon. If a given interior wall line is not necessary for the calculation of bracing, then there is no need to increase the number of braced wall lines for calculating the bracing length. This can happen when a second story requires 3 braced wall lines. A portion of the upper story doesn't extend over the bottom story, and the exterior wall needs to be broken into two separate braced wall lines. The story below has an interior wall line but doesn't require a bracing wall line. Then the first story wall line does not need to be counted as a braced wall line. The second case is when comparing required bracing for seismic requirements for wind and wind requirements. The fact that seismic bracing requirements require an interior braced wall line does not mean the braced wall line must be counted in the wind calculations. This can be done separately from the seismic requirements. In the end, there will be bracing on the interior walls due to the seismic requirements, but the wall line is not required to be considered for wind calculations. Here we see more adjustment factors being shown. You see the 800-pound hold down, interior finish, gypsum board fastening. If you do have a tighter nailing pattern on gypsum board, then there is a reduction. And then again, the horizontal blocking can increase the required amount of wall bracing. So just to review quickly, once we go into the tables and we see the wall bracing that's required, we need to make sure that we go in and select each one of the adjustment factors and see if that allows us to reduce the bracing or increase the bracing requirements. And we came back to this slide to look at these different adjustment factors because you have to go into each one manually. And this is the beauty of the wall bracing calculator. The wall bracing calculator is doing this for you, so you don't have to go in and make these calculations. So we just covered braced wall length requirements. Now we have braced wall panels and shear walls to resist lateral loads. The braced wall panel term is given to the lateral resisting element of the wall when prescriptive construction is used. Shear wall is the term given to this element when engineered construction is used. Braced wall panels have an assumed capacity and shear walls have a calculated capacity. The forces that begin at the wall then transfer into the roof. The connections then transfer the loads between the walls and the roof. The roof then transfers the force down into the walls and at each end of the structure through the connections. The end walls then transfer the load into the foundation, completing the load path all the way to the ground. The connections throughout the structure are very important. The load path depends on these connections to transfer the forces through the building to the foundation. Chapter 6 has table R602.3 that gives the number and size of fasteners for these connections. Here we see what the effects of lateral force failures can be. We have racking, base shear, and overturning, and all these are resisted by the bracing, the wall bracing itself, and the connections that are used. Here is an example of racking. In all fairness, this house did not have the sheathing fully installed on it, but this is just an example of what racking looks like during a seismic event. Another lateral load path failure we see is base shear, where the structure moves off the foundation. And the third type of lateral load failure we see is overturning. Here you see two structures that overturn. Typically, you're going to see smaller structures like this that get overturned. A lot of times, if it's a bigger structure, you'll see the destruction of it before you see the overturning, even though it may have the uplifting. The structure itself will not stay intact with overturning on some of the larger structures. Any building, regardless of its size or location, must be designed to safely resist the structural loads anticipated during its lifetime. Lateral loads are the forces that act on the side of a house parallel to the ground. Walls must be strong enough to resist the wind forces that push against the structure of the home. During a wind event, the wind pushes against one wall while it's pulling on the opposite wall. The walls on the other two sides of the structure are the braced walls and must hold it must hold the roof from moving. You also will see some uplift loads on the roof. The IRC applies to wind speeds less than 140 miles an hour. In high wind regions, the design of the building is required. Early wall bracing design is a critical aspect of the architectural and structural process. By considering wall bracing early in the design phase, architects and engineers can optimize the building's layout, particularly regarding window placement and material usage. This is a proactive approach that leads to more efficient, cost-effective, and aesthetically pleasing design. Adding the APA wall bracing calculator to the design process will be another added benefit. As we just mentioned, early wall bracing design can have benefits by optimizing the window layout, the material efficiency, structural integrity, and safety. There's also flexibility in architectural design. In these early stages, you can streamline the construction process with a good design, as all architects and engineers know. And ultimately, it's important that we have energy efficiency in these designs also. APA's wall bracing calculator can save designers time by generating a comprehensive project report. This report includes detailed information such as fastening patterns and can be seamlessly incorporated into the design. Material efficiency can result from proper collaboration planning then into design. Ultimately, an informed framing crew can place material correctly. Pre-construction meetings using the APA wall bracing calculator printout can show framers where bracing panels are required and proper fastening details for the sheathing and portal frames. Inspectors can walk onto job sites with APA wall bracing calculator printout and easily identify correct locations for window and door openings, portal frame details, and required wall bracing panel locations. As a reminder, correctly framed structure will allow for a quicker inspection, thus the inspector can get more jobs. The more inspections a jurisdiction can complete, the more structures move on to the next phase of construction. This is another time-saving benefit with APA's wall bracing calculator. We just looked at a project report on the previous slide, which is generated when you create a new project with APA's wall bracing calculator. So here's the input wall line information page as you see highlighted in the navigation bar. In the navigation bar, you see there's a second story and a first story, with the first story selected for our entry. We have a few more wall bracing topics to cover, which will show how impactful the wall bracing calculator is for many professionals. Code defines a braced wall panel as a full height section of a braced wall line with no vertical or horizontal offsets. The IRC defines a braced wall line as a series of braced wall panels in a single story. So in order to have a braced wall line, they have to be straight, run in each plane direction, required on every floor. A 4-foot offset each side of a braced wall line is allowed. Braced wall lines are not required to align with physical walls. Angled walls are allowed. We won't touch on angled walls, but we will look at the 4-foot offset for braced wall lines that is allowed. The load on a wall is resisted by the walls that are perpendicular to it. The longer load walls generate more load than shorter load walls. The longer resistance walls generate more resistance than the shorter resistance walls. Loading and resistance occurs in both directions. Here you can see the shorter load wall is being resisted by the longer resistance walls. The spacing permitted between parallel braced wall lines depends on whether their wind or seismic requirements are being considered. For high seismic regions, seismic design categories C through D2, the seismic design category limits the braced wall line spacing. Does this wall line meet the code? Yes, the wall line offset is not more than 4 feet from the imaginary braced wall line. In this case, the braced wall line could have been placed along either one of the wall segments. Does this braced wall line meet the code? Yes, this wall line offset's not more than 4 feet also. How many braced wall lines are in this example? A braced wall line can have offsets up to 4 feet, a total out-to-out offset of 8 feet. We could define the braced wall line that passes through wall line segment A, or we could define the braced wall line passing through wall segment C. But if we draw the braced wall line through the wall segment B, segments A, B, and C can be considered as one braced wall line. The opening in the wall line determines how wide the braced wall panel has to be. If the section of bracing has openings on either side of it, the taller opening determines the minimum bracing length. So if you have a door next to a window and you're looking at that panel in between the two, then you have to go with the door opening size. Our example is dimensioned differently than architects and designers would dimension plans, but we need to have the braced wall lines dimensioned, so this floor plan is dimensioned accordingly. Here we have a 6-foot offset at the garage, but we can use an imaginary wall line to make the front elevation wall a continuous wall without an offset. The distance to the adjacent braced wall line will be at 36 feet 11 inches using the imaginary wall line location. As we look at the input from the first floor front elevation, we'll see that the triple window does not allow for an end panel to meet the wall bracing requirements. But what happens in the wall bracing calculator when there is a non-compliant wall? We'll build out this wall and see how it can be changed. Typically, it's best to input the information as you view your plans, as the front elevation is usually at the bottom of a page. Here we highlight wall line 2 to begin inputting the wall line information. From our floor plan, we input the furthest distance to adjacent braced wall line is 36 feet 11 inches, using the imaginary braced wall line located 4 feet from the garage wall. The roof to eave height is 6 feet, and the wall line length is 40 feet. The wall height and story height, as it can be confusing to many, the wall bracing calculator works by just adding 1 foot to the wall height for the story height. Also, 12 feet is the maximum allowed in the wall bracing calculator, so you can't enter 13 feet as a story height. We'll have gypsum wallboard on the inside of all walls, and we can check yes for the horizontal braced wall panels joints being blocked, and this will be checked yes for vertically installed wood structural panels as well if they span from the bottom plate to the upper top plate. Next, we'll click on the wall line segment details to input the front elevation wall details. Above, the 2 tabs show where the wall line will be displayed as you input each section of the wall. To begin, we'll click on Add a Wall Line Segment, and then in our segment location, it will be at the start. Next, we'll be adding the segment type, and when we select the segment type, we're going to select the bracing segment. And as we select that, it's going to show that B1 up there. So when we've selected our segment type, next we'll select our bracing type. And here we're going to do a continuously sheathed portal frame. And when you make that selection, you'll see a pop-up that gives you a choice to either select 2x4 number 2 or better, or 2x6 stud or better. And we're going to select 2x4 number 2 or better here. And there are question mark icons throughout the wall bracing calculator. Here, the top of header will show this message when you hover over the question mark icon. The maximum header height is 10 feet, measured from the top of the foundation to the top of that header. A pony wall may extend up to a total of 12 feet above the concrete foundation stem wall. Once the first wall line segment has been placed, the remaining wall line segments will be added at the end of the segment location. As segments are added, We'll now select the other option in segment type with opening unbraced segment. We'll then select which type of opening to input. When we selected the garage door as the opening segment, we get a pop-up notice. This can be closed as we add the other portal frame for the garage door opening. Braced wall line for the right side of the garage will be another portal frame at garage, and we'll select right when this pop-up is shown. We can then enter the width of the braced wall and again input the same header height as the first entry. The 3 segments added now create the garage door opening as seen at the top of the page. If we make any changes from previously entered information, it's a good idea to click on the blue recalculate icon so that the wall is updated with the changes. Now, we're not going to show each part of this wall. It'd take too long to go through the slides, but we'll just jump ahead and show this wall built out. We can see at the top of the page, we have this front elevation just about built out for that first floor. We only need to input that last wall line segment. And the last wall line segment has been selected. And when we try to input the length, our final length is 1 foot 3 inches. But when we click on that, what do we get? Well, our final length is 1 foot 3 inches and it's not compliant. So we get an error explaining IRC placement requirements. This wall with a triple window located near the corner does not meet the requirement for the distance to a braced wall panel located within 10 feet of a corner. So here you can see we've changed the triple window to a twin window to create a 4-foot braced wall end panel. Now this is the wall that we just built out and made the change from a triple window to a twin window. And we can make this simple change within the wall bracing calculator to make this wall code compliant. And when adjustments are needed along a wall line, you can simply choose the wall line segment and make the change. Here we change the width of a triple window from 9 feet to a twin window or double window, the size of 6 foot width, which will provide 3 feet to be added to the last wall line segment. This will complete the front elevation wall line and give a code compliant status. The wall bracing calculator allows the walls to be input without having to follow along the perimeter either clockwise or counterclockwise. We can even move to the second floor and begin to input wall lines even if the first floor is not complete. It's important to be sure which floor is selected and which wall line you are working on, for example. We'll jump to the rear elevation. And I've made this mistake when jumping to the rear elevation more than once, inputting the wall line details for the rear elevation. You know, we typically read from left to right, and that's how I've made the mistake of putting the information in on the rear elevation. Of course, it works fine moving across the front elevation, going from left to right, but when we move to the rear elevation, we have to remember we're looking at this from the outside of the house. So we'll actually be moving from left to right also, but it's looking at it from the exterior of the house when you enter those dimensions. The selected wall line is shown in blue, and we will again input the wall line details, which will be the same as the front elevation with the furthest distance to adjacent braced wall line being 36 feet 11 inches and the roof to eave height of 6 feet. The wall length matches the same 40 feet as the front elevation. Selections are completed with gypsum horizontal joints blocked and not a single story residence. When the wall line details are complete, then again select the wall line segment details tab to input the wall, and we again jump ahead, not slide by slide for the wall line input details since we've done that before. Here you can see we have the rear elevation wall built out, and you can look at project reports at any time while you're creating this. And here you can see a project report for that rear elevation wall, and it includes a lot of helpful information. It shows the nails fastening pattern, 6 inches and 12. It shows that this wall section is compliant. There are a lot of good details as usual. The location of doors and windows are shown. So on the previous slides, I showed you with screen captures how to input information into the wall bracing calculator as we did the front and rear elevations. Here you can see the front elevation and the rear elevation. And I purposely skipped around just to show the versatility of the wall bracing calculator. You may have a more challenging wall that you want to input first just to see how it works, and then you can go and do the rest of the walls that you know may work. But again, I just wanted to show the versatility. When we move over to the second story, I'll do probably what typically people do is work counterclockwise around the house. But we'll start on the right side elevation and input those details. The furthest distance to the adjacent braced wall line is 40 feet. We already have our roof eave to ridge height selected. The length of this wall is 34 feet, 11 inches from our plans. We already have our wall height, story height selected, along with the gypsum. The horizontally braced wall panel joints are blocked, and this is not a single story, so we can start inputting the line segment details. Again, we're going to work from left to right, and as you can see on this plan, this is dimensioned a little bit differently than typical floor plans. Typically, you'll see floor plans dimensioned to the center line of openings, but in order to input this information into the wall bracing calculator, you need to know where the edge of the opening is, so we dimension to the edge of the openings just to make this easier to input. So we'll start with a bracing segment, continuously sheathed wood structural panel, 4 feet in length. Next we have a window to input. This is a opening in the wall itself, and we have twin windows or either single windows that are either 6.0 or 5.0 on this house. This window is a twin 6.0 by 5.0, just a typical vinyl window size. Our next segment is a bracing segment, continuously sheathed wood structural panel, 14 feet, 11 inches. And then we have another twin window, same 6 feet by 5 feet dimensions. And last, we'll finish out this wall line with a bracing segment, continuously sheathed wood structural panel that is 4 feet. So you can see over here on the right information panel that this is compliant. You can see the adjustment factors that were used. We can move over to the left elevation and input those details. Again, the furthest distance to the adjacent braced wall line is 40 feet. Our roof to eave ridge height stays the same. This wall line length is 40 feet, 11 inches because of the garage. Our wall height's 9 feet, story height's 10 feet. Same selections on the gypsum, the joints, and the story. So working left to right again, we have a bracing segment, continuously sheathed wood structural panel, 4 feet. And this wall pretty much matches up with the right elevation with the same selections. Again, just for simplicity, but I think even if you have different dimensions on here, this still moves quickly. And it's pretty intuitive. So once you have somebody that's a little bit familiar with dimensioning on houses, they can input this information. We have our bracing segments, continuously sheathed wood structural panel. This is the same 14 feet, 11 inches. our last twin window that we'll input. And then you see up top up here, this total segment is up to 30 feet 11 inches. We have a total line length that is 40 feet 11 inches, and from our plan, our last segment is 10 feet, so we know that this wall is going to work out. With our wood structural panels, they're going to equal 10 feet. And you can see we have a compliant wall here. And at this point, we've finished up our first floor, so we can look at our project report. And if we will look at the horizontal lines, lines 1 and 2, that'll be the front and rear elevations here. This is the rear elevation. You can see the details. Make sure that the lengths are right. Along with the front elevation, we can see the portal frames used here, continuously sheathed portal frames. You also get the fastening pattern at the portal frames. You can see there's a 3x3 grid. The wood structural panels, the sheathing on the house have a 6 and 12, 6-inch perimeter and 12 inches in the field. That's what makes these walls compliant. Same with the right and left elevations. You can see those same details. This is what your project report's going to look like. This is what you're able to assist with your plans. Code officials, be nice to have this when you go do inspections. You know what these dimensions are, what you're looking for, where the window and door location should be. So it's really a helpful project report. Again, we can move back over into the input wall line info and easily jump into the second story. I will be doing this one counterclockwise. So we finished up our first floor walls. See, the walls are compliant. We can click on the second story and start entering information. The second floor, we want to make sure we're on our front elevation. When we click on the wall lines details tab, furthest distance to the adjacent braced wall line will be from the imaginary braced wall line, 36 feet 11 inches. This wall line length is 40 feet. Our wall height is 8 feet on the second story with a 9-foot story height. Gypsum on the inside of the walls. The horizontal braced wall panels will be blocked, and this is considered a single story, so we can click on the wall line segment details. And our first bracing segment we're going to input will be a continuously sheathed wood structural panel from our plan. On the second floor, we see it is 7 feet 3 inches. And then we have another opening with a window, twin window, standard 6 feet 5 inches, 6 feet in width, 5 feet in height. And next, we have another bracing segment, and I'm going to enter these as its dimension. So we could put in one dimension for the 7.3 and 9.3 combined, but just because it's dimensioned this way and to show how easy it is to input, we'll just do it this way. And another bracing segment that is 9 feet 3 inches. And then we're to another window opening. The same, 6 foot in width, 5 feet in height. Whoops. 6 feet, 5 feet. And then we'll put in our last panel. Last panel width for the continuously sheathed wood structural panel from the plans is 4 foot 3 inches. So that gets us the front elevation, and it shows it is compliant. We'll move around counterclockwise to the right side elevation. We'll input our wall line details. Furthest distance is 40 feet to the nearest braced wall line. Roof to eave height is still 6 feet. This wall line length is 34 feet, 11 inches. Wall height is 8 feet. Story height is 9 feet, and our selections have already been done. Moving from left to right, we enter a 4-foot wall section. And then we have another twin window opening. This is a standard on our house here. When we get around to the rear elevation, we do have different window sizes. It's easy to change those window sizes as you move along. Our next one is 14 feet 11, and then we're to another window opening. Oops, I want to make that. It's not a bracing segment. Well, this is how you go back and make changes. It's good to show when you input stuff, it's easy to make a mistake clicking on these, but it's easy to go back out and get the right one selected. And for our end panel, we're going to have an even 4 feet. And that gets us, that you see is at the top, it's 34 feet, 11 inches. These walls are easy to input. And we'll move to the rear elevation. The wall line details, again, 36 feet, 11 inches to the imaginary braced wall line on the front of the house. This wall line length is like the front elevation, 40 feet in length. Our wall height has been selected along with our gypsum. Then we can click on our wall line segment details. This is where I sometimes have entered rear elevations incorrectly because I start from left to right looking at it from inside the house, and we need to be looking at it from the exterior of the house. So our first segment we're going to input looking at it from the exterior of the house will be a bracing segment, continuously sheathed wood structural panel that is 4 feet 3 inches in width. Then we come up on another window opening, 6 feet 5 feet in height. Another bracing segment, continuously sheathed wood structural panels. This one is 8 feet. Until we get to another window opening that's a little bit different sized. This is a single window on our plan, so it's a 3050. And we have another bracing segment of continuously sheathed wood structural panels that is 7 feet 6 inches in width. And once we have that, and again, it's easy enough to go back. If we needed to change this window or this window, you can simply click on there and change these window sizes. Or if you missed a window, you can go back and add a window. But as we move down through here, we'll add another window here, another 3050 window. And then our last bracing segment on this wall will be 8 feet 3 inches, and you'll see at the top it gets us to our 40 feet. And we'll move around to our last wall on the left elevation. Our adjacent braced wall line is at 40 feet. The wall line length here is going to be 40 feet 11 inches out to the front of the garage. And we have our wall height and story height already, so we're ready to input the wall line segment details. Our first is a bracing segment, continuously sheathed wood structural panel, and even 4 feet. Then we get back to our popular twin windows, which a lot of houses do have similar window sizes.
throughout, so this is not too unusual. What is unusual is this bracing segment. I know engineers and designers and architects are all wondering, this is not to scale, obviously, and we possibly could have put a brake line in on this dimension to maybe show it a little bit more clearly, but this house is obviously just an example, and we did it for simplicity to get these input. And then we're back to another twin window. 6 feet even. And as we finish up here, we will take a look at a project report and see what that looks like when you're totally complete. Our last bracing segment isn't even 10 feet. So that gets us our 4 walls on the second floor complete. And we can see all the walls are compliant. We can view the project report, where we can look at the first story that we did, first story walls, horizontal lines 1 and 2, and vertical lines A and B, or we can click on the second story and view those. Again, these are helpful printouts to have to assist when you're submitting plans to a jurisdiction to show that your project does meet the wall bracing requirements. And for code officials, it's nice to have this to go out in the field. You can see you do have obviously the window and door locations, but you also get the fastening patterns that are required. So 6 and 12 on the perimeter for our sheathing. And if we look at our garage door, we see that we have a 3x3 grid pattern called out for the portal frame. And we know which portal frame is identified. And when you download these files, go to export file, make sure you save the file as is, because when you go to upload it, you have to use the same file name. So when you do save it, don't change the file name so that you can upload it at a later time. That gets us through this presentation for the most part. Bob has a few notes that we need to review, so I'll turn it over to Bob.
Thank you, Kyle. Before we begin our Q&A, I'd like to remind you that your feedback on today's webinar is important. The QR code shown on the screen will link you to today's survey. So just open your camera on your smartphone and a link will take you to that survey. Alternatively, a link will also be emailed to you in about an hour. Please take a minute and fill that out. So Kyle, we did have a couple questions. I know we're getting close to our time here, running up against the clock, but let's see if we can at least get a couple of these, addressed. The first question we got in is, can you input a plan that has an offset greater than the code allowable?
Well, that's a great question and one that comes up a lot. And I would recommend that when you do have these questions, if we don't get them answered here, reach out to your local engineered wood specialist. But as we saw in our example earlier, we had a 6-foot offset at the garage. And in the real world, those garages can be offset 10 to 12 feet. In those cases, we have to separate those into 2 boxes. So we'll separate out the garage and input the garage by itself. And then we'll go back and do the same thing with the house. We'll take out the footprint of the garage, enter the walls for the house into the calculator. And then when both of those are compliant, then we know that the house will meet the wall bracing requirements.
Okay, very good. Thank you, Kyle. Another question we got is, people are using more devices, is can the wall bracing calculator work on other devices?
Yes, I know we've worked with, we've actually done this on a few different tablets. Of course, not all tablets in the marketplace may work with the wall bracing calculator, but I think most of the popular ones do actually work with the wall bracing calculators, which is nice to have out in the field. Typically, our cell phones are going to be a little bit too small to use, but if you have a tablet in the field, you should be able to use the wall bracing calculator.
Okay. Thank you, Kyle. I will point out we are running up against our time, and we do have some housekeeping things to take care of. And I'll highlight, as you mentioned, Kyle, if you submitted a question and we didn't get to that, we'll have your local engineered wood specialist reach out to you to address that question. And in talking about our local engineered wood specialists, I'll use this slide and point that APA does have field staff located throughout the country. Your local APA wood specialists, they're located in regions shown on the map. There are free resources available to help you with wall bracing assistance, with the calculator, any other questions you may have regarding engineered wood products or construction. You can find their individual contact information on our staff contact page on our APA website, apawood.org. So, feel free to reach out to them should you have any questions. Finally, I'd like to make sure that you're signed up to receive our APA update newsletter so that you will be notified of our next webinar, as well as future webinars and updates to APA publications and standards. To receive it, all you need to do, starting from the home page of our website, is to click Sign in the upper right-hand corner of the page. And in the menu that drops down, simply select Register. From there, you'll need to let us know what you'd specifically like to receive, which in this case is the APA update newsletter. Additionally, APA has resources to assist you at our help desk. These are in addition to our field staff people that I pointed out. They can be reached through email at help@apawood.org, or you can call them at 253-620-7400. At this point, I'd like to thank you for attending.